We're going to continue section 3.3 today, talk more about some transformations, getting into some stretches and shrinks as you can see there. So look at how to stretch and shrink a graph. We'll figure out what they are first. The transformation we covered yesterday, those are rigid transformations, as you can see here. Those didn't change the shape of the graph at all, only its location. So we moved up, down, left, right, but the shape of the graph looked identical to what the parent graph looked like. Now we're going to look at some non-rigid transformations, and these are going to actually change the shape of the graph that we're dealing with. So if we have this graph here, y equals c times f of x, where f of x is the function. Like we talked about yesterday, the location is key. So this c, I'm going to say, is on the outside. So when c, the absolute value of c is greater than 1, it's going to be considered a vertical stretch. When the absolute value of c is less than 1, in fractions, it's going to be a vertical shrink. So again, these are the outside that we're talking about here. So here are the three functions that we're going to look at. I'm going to pull up Desmos to look at these. So here is the absolute value of x and what that looks like. So 5 times the absolute value of x. That number is greater than, looking back here, this obviously number is greater than, you can go back to the previous slide. I'm going the wrong way. There we go. Now we're back to where we need to be. I think. There we go. C is greater than 1, so it's going to be a vertical stretch. So pulling up this again, so let's look at this. So this is my graph, this is my parent graph, a vertical stretch. So think taking the actual graph itself and pulling it vertically, pulling it upward, and it would look like this. It's going to make it skinnier. So a vertical stretch makes it skinnier. So now this next one, 1/5 times the absolute value of x, that's going to be a vertical shrink. That's going to make it, think pressing down on the original parent graph. That's going to make it wider, going to kind of make it flatter. So I'm pressing down the original one, I'm shrinking it, I get this as my new graph. So that's the vertical shrink and the vertical stretch. Now getting into horizontals, so C on the inside now, f of c times x, where c is on the inside, so this time it's the opposite. If c is less than 1, that's a horizontal stretch. If c is greater than 1, that's a horizontal shrink. So they're both opposite of each other. So here, let's look at these three functions. I'm going to have those up on Desmos. So here's our parent function of our parabola of x squared. Now this 2x quantity squared, so that value is greater than 1, so that is a horizontal shrink. Think pushing from left to right, pushing in on the graph, making it skinnier. 1/2 x, obviously the 1/2 is less than 1, so that's going to be a horizontal stretch. Think taking this blue parabola and pulling it wider out here to the new orange one. That's where it would stretch. That'd be a horizontal stretch, that is. So those, we have vertical stretches and shrinks. We have horizontal stretches and shrinks as well. So the next couple examples that I have here, I'll take you through on Desmos as well. So a couple things going on here. We're going to incorporate the rigid transformations from yesterday as well as the shrinks and stretches from today. So 1/2 times quantity x plus 3 quantity squared. So this tells me we have a stretch. This tells me we have a rigid transformation moving some way. So one way to think about where our starting point is, where our vertex is what makes this 0? I think we can all agree that -3 would make this 0. The 1/2 that is on the outside, that is going to be a vertical, one way or the other. Again, things on the outside move stuff vertically, and because it is less than 1, it's going to be a vertical stretch. So let's take a look at what that looks like. So I'll go ahead and get up there's our parent graph, 1/2 or just x squared. So now 1/2 x plus 3 quantity squared. Again, we said it's going to move what makes it 0, -3, so it's going to move it to the left 3 units. And then 1/2 is going to be a vertical shrink. So again, it's pressing down, making it a little wider. That's what that looks like. Again, we didn't move up and down at all because there's nothing on the outside here. We just shifted it to the left. Now this next one, we'll look at the absolute value. So there's the absolute value of x, and now we're looking down at this graph right here. So a couple things going on here. The negative flips it, the -4 moves it down, and the 3 is a vertical stretch. It's on the outside. It stretches it by a factor of 3. So let's see how this looks. So like we just said, we moved 4 down, we flipped it because of the negative, and it's a vertical stretch. So looking at the parent graph, here is 1, 1, 2, 2, 3, 3, and so on. From here, we've moved this down, so this is 0, 4. So as opposed to being over 1, up 1, again, it's a vertical stretch by a factor of 3. So I'm over 1, up 3. So this is over 1, down to -7 now. Is being over 1 again, up 1 again, so as opposed to being at 2, 2 as we were up here. Now I'd be at 2. I was at -7 right here, so now I'm at 2, -10. So again, stretching by a factor of 3. Moving on, we'll look at, let me get I guess I'll leave that parent graph up here because we're still dealing with an absolute value here for this next one. So absolute value of 2x minus 4. So again, taking what makes this 0. So this is a little trickier because we have the 2x and the -4. So you don't just want to say, oh, it moves it 4 to the left because of the 4 to the right because of the negative. Because there's a factor in there because of the 2. So think to yourself, what makes this 0? Here's my original parent graph at 0, 0. What makes that 0 is going to be +2. So I'm going to move only 2 to the right because that makes it +2. And because this 2 out front, that is greater than 0. So again, if we go back to our notes, and we have, again, on the inside, greater than 1, it's a horizontal shrink. So as we previously mentioned, think squeezing the graph and think pushing the graph in from the side and shrinking that by a factor of 2. So let's see what happens to this right here. So if we just move it over 2 units, and what makes it 0? 2 does. So move it over 2 units, there we go. So now once we get into the 2, we're going to get into shrinking this horizontally. So I'm going to squeeze this outside purple one, squeeze this one in, shrink it horizontally, and it will look like that. It will become skinnier. So again, I went from having, this was at 2, 0, and then 3, 1, 4, 2, and so on. Now I'm at, and all the way up here to, was it 4, 4, and so on. So now I'm at, on the blue graph, as opposed to being at 3, 1, I'm at 2.5, 1. As opposed to being at 4, 2, I'm at 3, 2, and so on. So that's how the shrinks and stretches work. We'll talk more about that tomorrow, but that's just the introduction to it.